Hello all, welcome back to my channel. In this video I'll be talking about stability of bodies. So if you do watch my earlier video, it was regarding the fundamentals of buoyancy. So the continuation topic of that will be stability of bodies. So let's see what is stability of bodies and what parameters are need to be considered to determine the stability of any body. So first of all, coming to the concept, when I'm talking about stability of bodies means I'm talking about two types of bodies. One is a submerged body and one is a floating body. So you know what is a submerged body, right? Which is completely immersed inside the liquid, inside the fluid or inside water. Okay, but a floating body means only some part of the fluid, some part of the body will be inside the fluid and some part of the body will be open to atmosphere. So now whether it could be a submerged body or a floating body, it is said to be in equilibrium or it is said to be stable when it comes back to its original position after a disturbance. Correct? Something like your elasticity. But this stability or this equilibrium condition of either a submerged body or a floating body will be dependent upon few parameters, and they differ from submerged body to floating body. If you are considering a submerged body, listen carefully, if you are considering a submerged body stability, then the two parameters which you need to consider are center of gravity and center of buoyancy. You remember in my last video I've explained you very clearly what is center of gravity. Center of gravity is the point through which the entire weight of the body acts. What is center of buoyancy? Center of buoyancy is the force of buoyancy is supposed to act, the point through which the force of buoyancy acts. So when you are considering the stability of a submerged body, you have to check the positions of G and B. When you are considering the stability of a floating body, the second case, you have two parameters which should be considered, which are center of gravity G again and meta center. So remember meta center, which I have explained you in the last class. Meta center is nothing but the point where the line of action of center of buoyancy or force of buoyancy and the normal axis of the body meet together, or it's the point about which the floating body starts oscillating after giving a small displacement. I already told you when I was talking about meta center is very much important in floating bodies. So to determine the stability of a floating body, you have to keep in mind the position of meta center and obviously by default center of gravity. So if you observe between the two cases, I'll tell you easy way to remember. Submerged body and floating body are the two cases where you talk about stability of bodies. In submerged body you have to consider G and B, and in floating bodies you have to consider G and M. G is common for both. Now let's talk about stability of a submerged body in detail. Now coming to submerged body, I'll take the example of a balloon. So balloon is completely submerged inside air. Yes or no? Yes. You see the outer periphery of the balloon is air, inside the periphery of the balloon also there is air. So it's a submerged body. The air is the fluid here. Alright. So if something like that, something like a balloon I'm talking about. So if a submerged body, not only that, if you take any wooden block and you completely submerge it inside the water, then it also becomes a submerged body. Nothing but the total volume of the body must be inside the liquid. Then it is called a submerged body, correct? So for such cases in submerged body, we have three conditions of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. So I already told you when you're talking about submerged bodies, you have to consider two parameters, which is center of gravity and center of buoyancy. Okay. So when you're talking about these two factors, say the position of your buoyancy is very much important. Nothing but the center of buoyancy, B. That is important. G will be constant for both the cases. Center of gravity and center of gravity will be common for submerged body and floating body. Where it matters to segregate between stable, unstable and neutral is regarding the position of B and M. So the position of B is important in submerged body, the position of M is important in floating body. Now when you talk about the position of B, center of buoyancy, if the center of buoyancy is above G, okay, above the center of gravity, then it is called as stable equilibrium. I'm repeating, if the position of center of buoyancy is above center of gravity, then it's called stable equilibrium. Next, if the position of B, nothing but your center of buoyancy, is below the center of gravity G, if the position of B is below G, then it is called unstable equilibrium. And if your B and G are at the same place, are at the single point, they act at one point only, then it is called neutral equilibrium. Alright, so that's what I've told. When W equal to FB and the point B is above G, then it is stable. If it is below G, it is unstable. If they are at the same place, it's neutral. So if your buoyancy force is upward, I mean the height of buoyancy force is greater when compared to center of gravity, means obviously your body should be stable. Why? Because it's submerged, right? It should be stable. But once your center of buoyancy is below, I mean below the center of gravity, means the height of center of gravity is more, but the center of buoyancy height is less. Means what? Only less amount of weight got displaced. Means what? It will be obviously unstable. Okay, so it's a common sense. Hence, according to technicality, if B is above G, it is stable equilibrium. If B is below G, it's unstable. And if B and G are at same place, it is neutral. Now let's talk about stability of a floating body. What I told for floating body, we have to consider M and G. Same like your submerged body only. There it was B and G, here it is M and G. So what I talked about stable equilibrium in a submerged body, if B is above G, it is stable equilibrium. Here also if M is above G, it is stable equilibrium. Okay, in case of floating body, if M, metacenter is above G, it is floating body. Floating body in stability condition. If M is below G, then it is unstable. And if M and G are at again same place, it is a neutral equilibrium. Same. There B and G, here M and G. If the point M is above G, it's called as stable. If the point M is below G, it's unstable. If M and G are at the same place, then it's said to be neutral equilibrium. So hope you understood this video very clearly. So what I want to tell you is, this concept is very much important for short answers for people who are writing your BTech exams, and for people who are preparing for your competitive exams. Obviously, the position of this M and G, B and G is very much useful for you in your competitive exams. They may ask you in multiple choice. So it's very easy to remember. Submerged and floating. In submerged, see, I'll tell you a shortcut. Submerged, if you see the spelling SUB, there is B there. So you have to remember it is B and G in submerged. So obviously the other one will be M and G. So if for stable, B should be greater than G, means B should be upper than G. For unstable, B should be lesser than G. Neutral, both are at same place. Similarly, just apply it to floating body. In floating body, stable means M should be upper. Unstable means M should be lower. M and G same place, it's neutral. So like this you need to remember. Okay, so hope you understood this video. I think this video will really help you a lot. And thank you so much. If you want the notes of this, you can please click on the description of this video. You'll get a link and you can download and study. Okay, thank you.